What you working on today, Peepaw? I got a drive made by Jetter. It's a Jetmove 215-480. Here's the full part number, type JM-215-480-RS. I've never worked on one of these before. So the complaint is that they saw smoke emit from this drive. This will be the first time I've ever gone into a Jetter. Let's see what we've got to do to take the lid off. Okay, here we go. We'll have to get a new one of those. That connector broke. Looks like all the screws. What's my holdup? Okay, looks like these DB9 connector. Screws have to come off. Smaller than normal. It's like 4.5 millimeter. There's a 4.5. That's it, 4.5. Alright, we're looser, but not quite all the way. So it might be hung up on this connector here. That's the trick. There it is. I see some puffed up caps right here. Those have spilled their guts. Disassemble it a little bit farther to assess the damage. Can't really tell. That might just be sawdust. Oh, there's a TO220 package that is burned up around the, oh, and it's cracked open on this side. That's where they saw the smoke come out. Let me get you closer and y'all can see that. You see right here the two electrolytic capacitors that have give up the ghost. They're bulged out on top, and right down here, if you can see it, this TO220 device has destroyed itself. Can you see the crack? We're not going to use that device no more. That's bad. Let's take a look at the other side of that smoke TO220 device and see if we have any damage all the way through the board. Right there it is. You can see where it smoked through the board right there. It's going to be a tough one. Here's the cover, and we see that we have UB minus, UB minus, UB plus, UB plus, UB plus, BRC and BRC, and up here BRINT. Now it looks like, just guessing, that UB minus and UB plus are the plus bus and bus ground, and the BRINT and the BRCs are where the braking resistor connects. I'm getting out of frame. There you go. Can you all see that? Now let's go over to the other side, and we have these two connectors. Here's what's called X62 and X1. We have U1, V1, and W1, and that is where the 400 volt 3-phase AC power comes in. I'm getting out of frame again. And we have motor, which is frame ground, U2, V2, and W2. So between the plus bus and bus ground and these connections right here to the motor and the line, we'll use our meter and diode test mode to make sure that the power devices are not shorted on this drive. And if they're good, then we can concentrate on that switch mode power supply. Here's the diagram of the 3-phase bridge IGBT power module, and the part number is 7MBR50SB120, manufactured by Fuji Electric. Now here's the 3-phase bridge section, RST, and the 3-phase diodes. Here's the positive, the bus plus side of the 3-phase bridge, and here's the bus ground side. And the output on the plus bus side of the IGBT is labeled P. The ground side is labeled N. Here is the brake and motor IGBTs. Here's B terminal. That's where you connect your regenerative braking resistor. Here's U, V, and W out to the motor, and the 7 IGBTs to perform those functions. Bus plus is labeled P1. Bus ground is labeled N1. Now the 3-phase bridge and the braking and motor IGBT section are separated here. Now on the drive, N and N1 were connected together by a trace. But on the bus plus side, they were separated with a relay in between P and P1. Now when we go to test this power module on the board, we will put our black lead with our meter set to diode test mode. We'll put our black lead on the P terminal and our red lead on R, S, and T. And we will be able to measure the individual diode drops of these 3 diodes right here in that 3-phase bridge. Then we'll put our red lead on N and our black lead on R, S, and T, and we'll be able to obtain diode drops of these 3 lower power diodes in that power module. Then to test these devices over here, we'll put our black lead on the P1 terminal, and we will measure diode drops with our red lead on B, U, V, and W of that power module. Then we'll put our red lead on N1, and we will have diode drops of B, U, V, and W. Okay, now let's go from P to R, S, and T. Here's P to R, 0.475. P to S, 0.475. P to W, 0.474 volt diode drop. Now here's P1 to U, 0.407. P1 to V, 0.404. P1 to W, 0.407. That's on the high side of the three-phase bridge and the IGBT. Now we're going to go from, put our red lead on N1 and N. Here's bus ground to R, 0.476. Bus ground to S, 0.477. Bus ground to T, 0.476. Now here's bus ground to U, 0.407. Bus ground to V, 0.407. And bus ground to W, 0.407. That IGBT is good. What fooled us a little bit was that relay being between P of the three-phase bridge and P1 of the IGBT. But once we bypassed that relay, we were able to get good diode drops on the IGBT side. Now we can concentrate on fixing that switch mode power supply. Wish us luck doing that. That's going to be a grizzly bear. Solder's not coming off very easily. So I heated up all the pins and the device fell off the board, minus one leg still on the board. And I can see the part number. It is L7815CV. And they're manufactured by ST. After we get the board cleaned up, we're going to have to figure out where the burnt traces go to. Okay. Now we got that removed from the board. Let's document where all these capacitors are on paper and on pictures, and we'll replace all of these capacitors right here. We're going to document their value, their Farad value, their polarity, and their position, as well as their voltage value. Looks like their polarity is all the same. It makes it a little bit easier. $220 at 50, $220 at 50, $220 at 50. That's $220 at 50. Okay. $1,000 at 25. 1,000 microfarad, 25 volts. Now how about the two that failed? What are they? A little bit dusty in there. There's some sawdust in there. 470 microfarad, 35 volts. Okay, both of them are 470 microfarad. .35 volts. 470 microfarad at 35 volts. There we go. Add a little bit of solder to help the old solder flow. Heat up one lead and rock your capacitor away from the lead you're heating up. It's the easiest way to remove capacitors from a board. After we have the capacitor removed from the board, we'll suck the solder out of the vias. Come on. Turn my iron up a little bit. That one don't want to come out. There you go. Let's get all the capacitors off the board. Turn my iron up just a skoshie bit because that ground plane is hard to heat up. The ground planes soak up a lot of the soldering iron heat. There we go. 2 removed. Is that all of them? Let's take a look. Yep, that's all of them. Okay. Caked on sawdust. A lot of caked on sawdust down here. Okay.